Welcome to today's lesson on chemical properties. You will need a copy of your chemical properties guided notes. The success criteria for today is you should be able to describe chemical properties of matter and clues that indicate a chemical change that is taking place. Also distinguish chemical changes from physical changes. The vocabulary you're going to need to know are chemical property, flammability, reactivity, chemical change, and precipitate. How would you describe the candles pictured here? You may describe the color or hardness, or you might observe that the candles are floating on water. You might even think that the density of the candles is less than the water. If you recall from the previous lesson, color, hardness, and density are all physical properties. However, you may notice that the candles are burning. The ability to burn is not a physical property because you cannot observe burning without changing its composition of the material that is burning. As the candle burns, new substances form. Most candles are made of paraffin, which is a mixture of compounds containing carbon and hydrogen. As the candle burns, the compounds combine with oxygen in the air to form water and carbon dioxide. The ability to burn is a chemical property, which is any ability to produce a change in the composition of matter. Chemical properties can be observed only when a substance and the sample matter are changing into different substances. Flammability is materials' ability to burn in the presence of oxygen. Materials that burn can be used as fuel. Sometimes people use kindling to start a fire or fuel in a vehicle. Chemical property that these examples share is their flammability. However, sometimes flammability is not a desirable property. There are laws that regulate the flammability of fabrics. The fabrics used in children's sleepwear must have low flammability. These fabrics are described as flame resistant because they are difficult to ignite. Reactivity is a property that describes how readily a substance combines chemically with other substances. Oxygen reacts easy with most other elements. Rust forms when oxygen reacts with iron and water. Rust is brittle, reddish-brown compound. A rusty chain or bolts are more likely to break than a new chain or bolt because the rust is weaker than iron. Nitrogen is a relatively low reactivity. Seawater is often stored in steel tanks located below the lowest deck of a ship. The seawater helps to keep the ship stable in the water. However, over time, the dissolved oxygen in the water reacts with the steel tanks and rust. Researchers have found that using nitrogen in the tanks displaces the oxygen and helps prevent rusting. Concept check number 1. Under what conditions can a chemical properties be observed? Question 2. Explain flammability. Question 3. Explain reactivity. Now would be a good time to pause the video, answer the questions, and then resume play. Question 1. Under what conditions can a chemical properties be observed? When substances in a sample of matter are changing into different substances. Explain flammability. Flammability is a material's ability to burn in the presence of oxygen. Explain reactivity. Reactivity is the property that describes how readily a substance combines chemically with other substances. When a banana turns color, it is going through chemical changes in the cells of the banana. A chemical change occurs when a substance reacts and forms one or more new substances. Chemical changes occur when a cake bakes in an oven. Leaves on a tree change color, food is digested in your stomach. 3 common types of evidence for chemical change are changing color, the production of a gas, and the formation of a precipitate. So changes in color. The exterior of the Statue of Liberty is made out of copper. When it was unveiled in 1886, it was brownish like a brand new penny. Over time, it oxidized and gave the greenish color, which is called patina, which protects the underlying structure from corrosion. The production of gas. In this picture shown is a model volcano. When you mix vinegar, which is acetic acid, and baking soda, which is sodium bicarbonate, it produces carbon dioxide and water. The bubbles here shown are from the production of the carbon dioxide. The formation of a precipitate. A precipitate is any solid that forms and separates from a liquid mixture. Another chemical change that you can observe in a kitchen is the curdling of milk. If you add lemon juice or vinegar and acid to milk, small bits of white solid will separate from the liquid when the acid is added to the milk. The proteins in the milk undergo a chemical change that alters their structure, causing them to stick together in clumps. They form a precipitate. Concept check number 2. 1. What is a chemical change? 2. List 3 common types of evidence for a chemical change. Now would be a good time to pause the video, answer the questions, and then resume. Question 1. What is a chemical change? A chemical change occurs when a substance reacts and forms one or more new substances. Question 2. List 3 common types of evidence for a chemical change. The 3 common types of evidence for a chemical change are the changing color, the production of gas, and the formation of a precipitate. Is the change chemical or physical? It's not always easy to distinguish a chemical change from a physical change. Even if you observe a color change, a gas, or a precipitate, you cannot be sure that the chemical change has taken place. For example, the water boiling in the pitcher on the top, the bubbles of gas that rise to the surface are still water. The horseshoe at the bottom, when it's heated, turns from a gray to a red. Despite the color changes, its iron is still iron. When matter undergoes a chemical change, the composition of the matter changes. When matter undergoes a physical change, the composition of the matter remains the same. Concept check number 3. How do chemical changes differ from physical changes? Question 2. A pat of butter melts, then burns in a hot frying pan. Which of these changes is physical and which is chemical? This would be a great time to pause the video, answer the questions, and then resume. Question 1. How do chemical changes differ from physical changes? A chemical change produces new substances. A physical change produces no new substances. Question 2. A pat of butter melts, then burns in a hot frying pan. Which of these changes is physical and which is chemical? Melting is a physical change. Burning is a chemical change.